we've got negative radicals that we've got to first change into imaginary numbers, or complex, actually imaginary numbers. So let's start with the negative 8. We're going to simplify that first. So negative 8, I'm taking the square root. That would be negative 1, right? The square root of negative 1 times the square root of 8. And so the square root of negative 1 times 8, I can rewrite as the square root of 4 times the square root of 2. So square root of negative 1 is equal to I. Square root of 4 is equal to 2. And the square root of 2 I just leave alone because it's an irrational number. And then I just reorder my terms. Reals first, then imaginary, then radical. All right, let's look at the negative 3. Square root of negative 3, I can rewrite as the square root of negative 1 times the square root of 3. Square root of negative 1 is I, and I can't do anything with the square root of 3 because it's irrational. So now I come back over to my expression, and I'm going to use my imaginary numbers to replace my square roots of negatives. So this square root of negative 8 is going to be 2I root 2. The 15 can stay. And then inside this square root of negative 3 is going to become I root 3. So now I've got to distribute. So when I distribute, I do this times this. I'm only multiplying the real number out in front, which is 2, by the real number on the inside. So I would get 30 I root 2. Okay, just as if it were an x. If it was 2x times 15, I would get 30x. So since I have 2 I root 2 times 15, I get 30 I root 2. Now I go here, and there's no real number, right? The real number that I could say is I could say that this is a 1, right? So 2 times 1 is 2. I times I is I squared. And then root 2 times root 3 is root 6. All right, now I can simplify this just a little bit further. I'm going to keep this 30I root 2 because there's nothing I can do with that. But in the second part, I have an I squared. And remember that I squared is the square root of negative 1 times the square root of negative 1. And when you do the square root of negative 1 to the second power, you just get negative 1. So I can replace my I squared with a negative 1. So I would have 2 times negative 1 times root 6. And then that's going to change things just a little bit. That's going to give me 30 I root 2. And then 2 times negative 1 will be minus 2 root 6. And because my roots are different, my radicands are different, I can't combine these. So that's where it stays. That's where we end. So anytime you have negative radicands, like we have here with the negative 8 and the negative 3 inside the radical, you must convert them to imaginary numbers first. Okay? So convert to imaginary first. All right, so let's do some more multiplying with these imaginary and real numbers, so complex numbers. In order to multiply these, we're going to use the FOIL method. Because, like I said, it's treated the same way we would treat binomials, x plus 2 times x minus 5, something like that. So the FOIL method is first, outer, inner, last. So we're going to do the first terms, and we get 28. Then we do the outer, and we get plus 70i. Then we do the inner, and we get plus 8i. And then we do the outer, and we get plus 20i squared. And just like we saw with quadratics, we have to combine like terms. I've got a 70i and an 8i. So when I combine them, I get 28 plus 78i plus 20i squared. Now, I squared, like we just saw on the previous slide, is the square root of -1 times itself, which is just -1. So anytime we see I squared, and that's a dot, not a negative, anytime we see I squared, we can replace it with a -1. So that will give us 28 plus 78i plus 20 times -1. And then that will give us 28 plus 78i minus 20. And then we have like terms again. 28 minus 20 will give us 8 plus 78i. And that would be our final answer. Right, so we FOIL, combine like terms, then anytime we have an I squared, we replace it with -1, simplify and combine like terms again, and then we get to our final answer. All right, so let's take a look at another one. This time, we're going to multiply a complex number by its conjugate. And if you didn't watch the previous lesson, the conjugate just means that we change the sign in between the real and imaginary parts of the complex number. So if my complex number is 4 plus 7i, then my conjugate is going to be 4 minus 7i. But we're going to do the same steps we just did previously. We're going to use FOIL. So we're going to do first, and that will give us 16. Then we're going to do outer, and 4 times -7i is -28i. Then we're going to do inner, and that is +28i. And then we're going to do last, and that will give us a +7i times a -7i is -49i squared. Just like we did previously, we have like terms that we can combine. A -28i and a +28i will give us 0. So when we combine like terms, we'll have 16 minus 49i squared. And just like we saw previously, I squared is equal to the square root of -1 squared, which is -1. So we're going to replace our I squared with -1. 16 minus 49 times -1. And then we get 16 plus 49. And let's see, 16 plus 49. 16 plus 50 would be 66. And then I take one away, so I'd get 65. So something that's really important to point out here, a use of the conjugate, is if we need to eliminate radicals. Because remember that I, even though it doesn't look like it, I is really a radical because I is equal to the square root of -1. Sometimes, like we're going to see in the next few problems, we have to get rid of the radical altogether. And a very efficient way of doing that is to multiply any complex number by its conjugate, because in the end, those middle terms will cancel out, and I'll be left with a real number, like 65.